Hello students. So let us solve a question from CSIR NET 2023 December. The question ID is 705050. So wonderful question from Bohr model. The concept of effect of finite nuclear mass in a line spectra. So in that question, it is mentioned that the ionization potential of hydrogen atom, this is given 30.6 electron volt. Also, it is mentioned that the longest wavelength of Balmer series for hydrogen atom case, this is lambda h. And for deuteron case, that longest wavelength of Balmer series is lambda d. Okay. So what you have to find? You have to find the approximate value of this quantity. Lambda h minus lambda d divided by lambda h into 100. So this quantity you have to find. So wonderful question. So let us solve this question step by step. So as you know, in the Bohr model, if you have a two atomic level, electronic level, upper level has principal quantum number Ni, lower level has principal quantum number Na. If the electron make transition from upper state to lower state, there will be emission of photon. The wave number of this photon can be calculated, that is 1 by lambda. From the conservation of energy, you can find this. So this will be Rydberg constant. Of course, this should be Rydberg constant due to finite nuclear mass. And then you have 1 by nf square minus 1 by ni square. So when you are dealing with Bohr Balmer series, of course, the final state quantum number, this is fixed. And Ni can be 3, 4, 5, 6, and so on. You'll get maximum wavelength of Balmer series if the electron make transition from 3 to 2. So of course, I can write this, if you write this Rydberg constant, this is also important. So this will be minus E1 by Hc. Remember, here I have not including Z value here, because both hydrogen and deuterium, both cases Z is 1. If you have a Z more than 1, so of course you have some Z square will be here. And E1 will be the ground state on energy of hydrogen. Now see, if you include that effect of finite nuclear mass, of course, E1 will be, E1 you have to take that is due to finite nuclear mass. So this will be vary due to finite nuclear mass. So of course, R will be vary. Because here E1 is the ground state energy of hydrogen atom due to finite nuclear mass. That you have to keep in mind. Okay. So you have to keep in mind that Z square I'm not taking, because for both case you have a Z equals to 1. Well, so now let us proceed. So I can write this 1 by lambda h, wave number for hydrogen atom. So of course this Rydberg constant due to hydrogen atom, and this will be 1 by final state, this is 1 by 2 square minus 1 by 3 square. And let us take this is your equation number 1. The same way I can write 1 by lambda d. This is the case for deuterium atom. So I can write this will be Rd, then the same quantity, because for both case maximum wavelength they said. So this will be fixed, 1 by 2 square minus 1 by 3 square. And let us take this is your equation number. Now remember, this RH you can write, this will be reduced mass of hydrogen atom divided by Me, and then you have a Rydberg constant due to infinite nuclear mass. Remember, this quantity is fixed. This value is well known. So reduced mass of different nucleus is different. That leads to different Rydberg constant value of different atom. I know for hydrogen atom case, you have a proton at the nucleus, and you have a orbiting electron. So you can find that reduced mass of the system. Of course, I can write this RH. This will be mu s. This will be mu mp, then me divided by me. You have this and mp plus me and r infinity. So this me will be cancelled. The same way, if you see that case of deuterium, so deuterium contains on proton, on neutron at the nucleus, and you have a orbiting electron. So I can write this RD at the same time. So this will be at the center you have a two nucleons. I can write that the mass of nucleus is 2 times mp, and me divided by me, then 2 times mp plus me. And you have a this quantity, this is fixed. Well, so this is that form. Now directly I can write from this equation on, what I can say that lambda h, this will be, see this quantity, I'll assume this is your, let us take this quantity, this is k, because they're fixed for both case. So what I'll say that lambda h, this will be simply 1 by rh into k. The same way, from equation 2, I can say that lambda d, this will be 1 by rd into k. And you already have calculated that rd and rh. So now I can proceed to get this value, approximate value. Well, so I'll substitute this value. So you have 1 by lambda h means 1 by rh into k, then 1 by rd into k divided by 1 by rh into k. Now see, this k will be cancelled. This is a common. So from ऊपर और नीचे cancel हो जाएगा. बचा क्या रहेगा? Only you have 1 by rh minus 1 by rd divided by 1 by rh. Now see, I already have calculated rh value. I'll substitute that. So if you substitute this rh, so 1 by rh will be how much? From this equation, you can see this will be how much? Simply mp plus me divided by mp into r infinity. In the same way, 1 by rd, from here you can see, because this me will be cancelled here. So what you have? You have 2 times mp plus me divided by 2 times mp into r infinity. And you have 1 by rh. So this will be how much again? mp plus me divided by mp into r infinity. Now what we'll do, I'll divide this this by this. That will give you how much? This will be, of course, you have 100. That you have to keep in mind. This is important. You have 100. That makes a problem also. So अगर divide करेंगे हम, so if you divide this by this, what will you get? You will get simply 1, because this is identical term. Now if you divide this by this, you can see what will have. This r infinity cancel हो जाएगा, mp cancel हो जाएगा. You can see this will be cancelled, this will be cancelled. So what is the left? You will have 2 times mp plus me divided by 2 into mp plus me into 100. That is given. Okay. So now I'll substitute that value of mass of a proton. So as you know that mass of a proton is 1836 times mass of electron plus me divided by 2 into mass of proton, that is 1836 times mass of electron plus mass of electron. Into 100. So this will be cancelled. ऊपर me कॉमन है, नीचे भी me कॉमन, सेकंड टर्म. तो आपका कैंसिल हो जाएगा. What will have at the end? 1 minus 2 into 1836 plus 1 divided by 2 into 1836 plus 1. Right? And you have a multiplication of 100. If you solve it, you will get 0.000 0.027%. So they ask you to find the closest value. So this is closest to 0.03%. So according to the given option, C will be correct. The percentage of this value, that will be 0.03. Okay. Okay. Thank you, students.